Okay, welcome ladies and gentlemen to section 2.1. We're going to be beginning our study of functions and other types of functions as we get going. The beginning here is going to be linear equations in two variables. And that's things you've seen before, like y equals mx plus b. So y equals 3x plus 7, that's a linear equation in two variables, right? So you got y and we have x. So looking at linear functions, we have slopes, which are very, very important to linear functions. And we're going to look at some equations for them. So by definition, slope is the rate of change of a linear function. It's how much it changes vertically over how much it changes horizontally. So we say this, that it's the change in y over the change in x as a fraction. Other ways we can say this is delta y over delta x. If you're a science kind of person, you may have heard the word delta before. Delta just means change. So this means the same thing as the line in front of it. This is the delta y, which is change in y, over change in x. We know it as rise over run, simple terms, but all of this is the same thing as if you remember the straight up formula. M equals y2 minus y1 over x2 minus x1. That's the old standard formula. That's slope. M represents slope, as you might remember. There are a couple different forms that we need to know, the different ways to write our equations. The first one is one of the most important ones, one of the ones you guys see most often. That's slope-intercept form. And that's y equals mx plus b. So m is your slope, that's obvious. And then the coordinate 0b is your y-intercept. And that's why it gets the name slope-intercept form. I'm going to add one right here just because I didn't put on here, but it's really kind of important. And this is the point slope. This actually comes in handy as you guys advance yourselves in mathematics. This is y equals m times x minus x1 plus y1. So x1, y1 is a coordinate, and m is your slope. And this is a super handy equation to have because you can simplify this down to slope-intercept form rather simply. The last form I want to have on here is the, oops, I did put it on here. I thought I had something else on here. So there's your point slope form. Like I said, it's very handy, very, very handy to have. Okay. More of these, more types of equations. Horizontal lines. Horizontal lines look like y equals a number. I let it be a. So y equals 7. If I have a line that goes like this horizontally at 7, this is the line y equals 7. The slope for this is 0. So the horizontal lines have slope 0. We also have vertical lines. Vertical lines are x equals a number. So if I had some line that went like this, way out here, let's call that 5. This is the line x equals 5, and the slope is undefined. Because technically it's rising forever and it's not running. So the run is 0 and you can't divide by 0. That's why we say our slope is undefined. The general form for an equation is ax plus by plus c equals 0. And what this basically is some books really like this form, some others don't. But if I was to give you y equals 3x plus 7, in order to put it to ax plus by plus c form, I just have to get everything on the same side and set it equal to 0. So I'm going to subtract y from both sides. And I have standard form. It's as easy as that, or general form is what they're calling it. Or if I was to have 1/2 x minus 7 equals 3/2 y. So again, I need to subtract 3/2 y. Now the only difference here is a, b, and c are normally whole numbers. So in order to get rid of these fractions, I'm going to multiply by 2. I get x minus, or 2 times 1/2 is 1. So x minus 3y minus 14 equals 0. And that's my new general form for that particular equation. So notice we get our equation to slope-intercept or something like this, and then we rearrange it to get into general form. All right, I want to write some equations here. The first equation that I want to write is for the slope of 3 that goes to the point 1, -2. Now, I gave you a couple slides ago the equation called the point slope. Well, that means I need a point and the slope, which means I have it. So it's y equals m times x minus x1, which is 1 here, plus whatever y1 is. And if I simplified this to get it into slope-intercept form, I get 3x minus 5. So notice my slope is 3 and my y-intercept is 5. What about this next one? What if I said it just goes through 2 points? Well, with any of our equations, we need a slope. So we need to find slope. So I need to figure out what is m. M is 1 minus 0 over 3 minus -2. So I did y minus y over x minus x. So I get the slope of 1 over 3 minus -2 is 5. All right, so that means I have a slope and a point. Doesn't matter which one you use here. I kind of like to use the ones with zeros. So it's x minus a -2, so this becomes a +2, plus 0. So if I distribute to put in slope-intercept form, it's 1/5 x plus 2/5. And then if I wanted to put this in general form, I'm going to multiply everything by 5. And I'm going to get 5y equals x plus 2. And I'm going to get everything on one side, so I'm going to subtract 5y. So I get x minus 5y plus 2 equals to 0. Now, I only put it in general form to show you that example. You're not always going to have to put things in general form. It depends on the question being asked. All right, what about this one? The points 3, 4 and the point 3, 1. So if you go to do slope, now some of you might be able to know exactly what this is already, but if you went to do slope and you did 4 minus 1 over 3 minus 3, you get 3 over 0, which means it's undefined. Well, an undefined slope means it's vertical. By the way, that's the spelling for vertical. Don't misspell it, please. It means it's a vertical line, so it's x equals, well, it's whatever the x coordinate is. So they're both 3. And that should be the hint there. They're both 3. So I didn't even need to do all this. If I would have noticed that both of these x coordinates were 3 and the y coordinates were different, it's just x equals 3. Likewise, something like this. You could go through the whole motion here, find the slope, 2 minus 2 over 2 minus negative 1, which is 0 over 3, which is 0, which means it's horizontal. So it's y equals, well, look, they're both the same y value, so that's y equals 2. Oops, I have one more example here. What about goes through these 2 points here? 0, 4, and 1, negative 1. So I'm going to find my slope. I'm going to go 4 minus, oops. I'm going to go 4 minus negative 1 over 0 minus 1. So I get, okay, so slope 4 minus negative 1 is 5 over negative 1. So my slope is negative 5. I get negative 5 times x minus, I like the ones with zeros, so x minus 0 plus 4. Negative 5x, if I distribute that, that becomes 0, so I just get a plus 4. And there we go. We have our examples, and we have them written. Okay, one of the other things that we do with with linear functions is we try to determine parallel and perpendicular lines. And you might recall this from a little bit of Algebra 1, Geometry, Algebra 2. We do it in all 3 of the classes. And we do parallel lines and perpendicular lines quite often in geometry. So we say if two non-vertical lines are parallel if and only if their slopes are equal. So if I gave you the line y equals 3x plus 7 and the lines y equals 3x minus 5, these are 2 separate lines. They're completely different because they have different y-intercepts, but the slope is 3, and both of their slopes are 3, so therefore they are parallel. But I could ask different kinds of questions. What if I said we have the line y equals 3x minus 7, and I want parallel through the point 1, 7. Well, parallel means same slope, so I get y equals the slope. Well, now I'm just going to go through the point 1, 7, so I get x minus 1 plus 7 using that point slope form. And I get y equals 3x minus 3 plus 7, and y equals 3x plus 4. There we go. We have a parallel line that goes to the point 1, 7. Now, if 2 non-vertical lines are perpendicular, it is only the case if their slopes are opposite reciprocals of one another. The y-intercept actually has no bearing on this. So if I gave you the function y equals 3x minus 7, or 3, whatever I'm going to write there, this slope is 3, and therefore the perpendicular slope is negative 1/3. The reciprocal of 3 is 1/3. Opposite reciprocal. Opposite means negative, or change the sign. So I would have to have a y equals negative 1/3 x plus blah, whatever the question might be. And it goes the same with all of them. If I want perpendicular, I need opposite reciprocal slopes. You have to remember there might be a tricky little question where it says 3y minus or equal, or no, let's actually go general form. 3x minus 4y plus 7 equals 0. The slope is not 3. You must be careful of that. I need to add 4y to both sides. But the slope is still not 3 because y is not by itself. So I need to divide everything by 4. So this gets 3/4 x plus 7/4 equals y. Therefore, my slope here is 3/4. So be careful on those ones. Here's your assignment. I should have an assignment sheet ready for you guys tomorrow in class. I hope you guys learned a little bit of stuff or refreshed your memory a little bit. Have fun with this, and I'll see you guys tomorrow.